Okay, so you have a final project that you need to get finished. Anybody have any questions about the final project right now? Okay. I thought I'd talk a little bit about data and that sort of thing. It tends to be, there are two areas that usually come up kind of weak on the final project. One tends to be the data, one tends to be the analysis. You know, I've had projects turned in where, you know, after a semester of learning all these techniques, they have a couple columns of data, they take a couple averages, and they say, oh, look, you know, here's the answer. No p-value, nothing, no confounding variables, nothing like that. And, you know, I'd like to think that we've made that clear that that's kind of important. So I thought I'd take another sort of hypothetical case, you know, a study that anybody could do, but and actually I think I've probably seen some small studies similar to this. But suppose I just have a question of like, does practice make perfect? Okay, so that's sort of my general question. And actually I knew a diving coach who said, no, practice doesn't make perfect. Perfect practice makes perfect. But actually I never saw tens out of his divers, so I'm not sure that was, maybe they just didn't have perfect practice. I don't know. But to try to get at this, I guess I need to start whittling things down, and you know, what I could do is just simply pick something I want them to do, right? So maybe what I want somebody to do is to you know, take a dowel, a rod of some kind, and I would like to know how well they could mark the halfway point, just looking at it. You know, not measuring it, but how well could they take something that they can't really bend, you know, so, and pick the halfway point, and then ask, well, if they practiced it and got feedback, could they get better at it? Okay, and you know, why would I pick something like this? Well, I don't think it's something we do real often. So I could pick something that we do a lot. You know, like lots of people like to throw balls into various hoops or things like that, or paper wads into baskets, and you know, that sort of thing. Or we like to hit a ball with a bat, or you know, a golf club or something like that. You know, so I could pick something like that, and that would be fine. But on the other hand, I could also pick something that we don't do much, or at least most of us probably don't do a lot, and that would be like just sort of looking at something and saying, where's the halfway point? And so now I have to talk about data. Right? You know, what am I going to do, and what are my two variables, and that sort of thing. And probably, you know, my response variable is some sort of measure of how well they did. Okay, let's just say this is unit 1, whatever that means. Maybe it's a foot long thing, a meter long thing, an inch long thing, whatever, but it's 1. It could be 4.4 inches, and I could still call that 1. Okay, it's 1 4.4 inch length. So, I could take something like that, and maybe a reasonable measure, I'm not sure, is that I could ask, what's the length of the shortest piece? Okay, so my response variable is length of shortest piece. So it's going to be some number between 0 and a half. Hopefully not 0, right? But and so it's this value. I'll just call it x for now. It's probably definitely bigger than 0, but it can never be bigger than a half, because the shortest piece could never be more than half the whole thing. And so I could do something like that. But I really, if I'm asking about practice and making perfect, then I really need a before and after. Okay, so my real life data, as I talk about this sort of question, is, I would need to collect a bunch of numbers that were befores and after for each person who's practicing. And that's another thing I should talk about, is each observation should be a person. Okay, I guess it could be something else. I mean, it could be a duck, but I don't know. I'm not going to try to get a duck to tell me exactly halfway on a stick or something. So, I'll probably work with people, but that's something that I should mention in the data, is these responses here are paired by person, and I should point that out. And, so I may have numbers like, 0.4 and 0.44, 0.49, 0.48, 0.35, 0.45, things like that. And, what I'd be hoping, of course, is that if practice does help, I would hope that these numbers are closer to a half than those numbers. And so, for instance, I could talk about improvement. Right? Now, that's something I would also have to discuss in my data, though, is my improvement just the after minus the before? Or even though these are all kind of the same numbers, right? They're fractions near a half. If I had somebody who happened to be just really good at this to start with, had never really practiced it, but amazingly, they're quite good to start, they can't have as much improvement as a person who's really bad. Okay, so now, if you, and here's what I want to get across on the data, is these are really good questions, and you might get comments about these sorts of things, or questions about these sorts of things from people on your voice thread. I hope you do. If say you've thought about this, you've gotten it this far, and you say, okay, what I'm really interested in is the difference here, the after minus the before, and I want to see improvement, right? This should be closer to a half than that should be. Even if in the end, you probably, maybe you should have looked at relative error as opposed to absolute error here. Again, because it's somebody who's really bad at the beginning can easily get better, but is that the same thing, as I mean, if you're that bad at it, maybe you're just lucky when you do this. But it's not clear. I mean, it's something to think about, and so you either want to look at just the absolute difference or the relative difference, but that's where you're going with it. Okay, but your raw data, right? Your raw data would look like this, and you want to put that into your project. So this is the sort of response variable we have, and you'd want to point out it's paired by person, and and all that. And then, well, it's about practice, so probably my other variable is some sort of practice. And I mean, a pretty straightforward thing would be I could just give them a bunch of similar rods like this and ask them to try to divide it in half and have some way to check it and give feedback. Okay? And so probably what I would keep track of is the number of practices they did. That might be a good way to go. And so I would keep track of that, and maybe this person did 10, and this person did 5, this person did 10. Right? This could be an experiment where I tell them how many times they get to practice. Okay? So, I could do something like that. And now in the very simplest sort of thing then, as I talk about this data, what I'm kind of hoping to see then is that I will have, number of practices and after minus before. Now again, should it just be the absolute difference? So I could do after minus before, or I could do after minus before divided by before for a relative error. Okay? But again, in many ways, it doesn't matter as long as you talk about it. Okay? The big thing I want to get across is you don't want to talk nonsense. You don't want to just write stuff to write a bunch of words. But you want to be very thorough about why you are choosing your variables, what you expect to see from collecting data, right? So how would I collect data? I would bring people in probably on a Saturday afternoon and give them the task to do, give them some time to practice, and then have them do it again. Right? That'd be a pretty simple thing. Now, again, I could talk about, well, do I want to just do it in one sitting? Do I want to do it over a week? Well, that's something I would talk about as to how I'm collecting my data. Again, is there a right answer? No. The right answer is that you tell me about it. Okay, so, I would show something like this for my data, and then, I would expect, what I'm hoping is that, I might see something like this, right, as things get better as somebody has more practice. That's the type of thing I would like to see. Okay, now though, let's just start with, okay, how would I have that data, right? So here, you just need to show a few lines. Okay, so your report, if you had about 5 lines like this, that would be great. Now, I need to add more columns to it, but if you had like 5 lines of something like this, that would be great because it's showing me how this would look. And so, suppose I go here, and so in a spreadsheet then, I could just put something like, what do you call it, participant ID, right? That's kind of getting across, I'd have each participant, they'd have an ID. Now, it could be something as simple as 1, 2, 3, right? 1, 2, 3, and so forth, 4 and 5. And then I would have my before, and again, 0.4 and so forth. Now, here's the thing. At some point, I do want to make a plot. And so I want to talk a little bit about putting in the data. So for just a data, showing me in your report what your data look like, you could, if you don't have a data file that you found somewhere, with the kind of stuff you're looking at, that's fine. You can make up data. Okay, and here, just for a small table, you could just truly make it up, put in some numbers. But the thing is, we do want to see some plots and tables and so forth. And here, I'm talking numerical data. Right? I'm talking about numerical data. And so, what I need to do is probably generate enough points to make a decent looking plot. Now, how might I do that? Well, the easiest way is to just use the random number stuff we've used before. Okay, so here's before and after. And so, I could just do something. Now, I want them to look decent, right? And so, I could think, what's sort of the worst somebody's going to do? Well, maybe a third, right? I don't know. Somebody might do worse. Again, I haven't identified my population to you or anything like that, but I just want to look at my main data to start with. And so if I have numerical data, I can decide, do I want to try to make it look like there's an answer? I don't have to. So I can make it completely random. And now, what would I mean by completely random? Well, say I think the worst anybody could ever do is about 0.3, and the best, of course, is 0.5. So I could go in here, and I could just generate a random number between 0.3 and 0.5. Now, there are various ways to do it. I'm not sure what you think would be the easiest. So, one way is I can generate a random number between 0 and 1. And if I compress that number by 0.2, if I multiply that number by 0.2, and add it to 0.3, I'll always get a number between 0.3 and 0.5. So that's one way. And if anybody has a question on something like that, all you have to do is ask. So, I can take 0.3 plus 0.2 times that random number between 0 and 1. And, oops, what did I do? Oh, forgot a times there. There we go. And there is my random number between 0.3 and 0.5. And I could just do that for both of those. Now, and they'll keep changing every time I do this. All you have to do, if you don't want that to happen, is I can copy all these. So I'll highlight that, do a copy, and if I do a paste special and only paste number, then those numbers don't change when I do something. Oh, wow. I hit enter and I don't know, didn't expect it to paste like that. But notice the numbers over here changed, but not the numbers up here that I did a paste special. So, these keep changing, these do not. So that's all you have. Once you have them, you can keep them from changing that way. I'm going to get rid of them for now. And now, so those are just random. If I do an after minus before, so equals this after minus the before. These are just truly random numbers, so I get stuff all over the place. Minus, I get negative stuff, positive stuff. And then, again, my number of practices, I could do the same thing. Well, the number of practices should be an integer, so I could use, for this, I could say for my practices, that might be better using that ran between function. And, how many practices? Well, I could have a case where a person doesn't get to practice. They do it once and then they try it again after some amount of time. So I could have that go between 0 and, who knows? It could be 10, it could be 20. I could let somebody do it 100 times. It's my study, right? But I just need to talk about, why would I pick, say, 20 times or something like that? But yeah, maybe I would go with 20. And I put that in and have that. And then, now I can make a plot. Okay, the columns are actually in the reverse order I would like, because the first column is my response and the second column here is my explanatory. But once I make that data, then I can make a plot. Okay, questions about that? Okay, because you are going to want to have a data file, right? Actually, probably more than one, depending on what you're doing. Because I probably would have my raw data without the after minus before stuff, and then I would have my analysis data where I would actually make that after minus before column. Okay, because you want to think about it as if you were really going out and collecting these data, what would they come in as? And here they would probably come in as a before and after and a number of practices. And again, you can make them any way you want. Here it was simply random. Now, another way I could do it is I could have the befores be simply random, Okay, but the afters, I could actually take the afters and make some kind of formula that said, oh, still make it kind of random, but always make it better. Okay, so how would I do that? Well, I need to pick a number between 0 and 0.5, but I need to start with whatever this number is here. So it starts to get a little more complicated, but I could do it. I could start with, by highlighting that, I'll click that number over there. And then, now I can't take 0.2 because clicking this number over here, if I had a 0.5 and then I generated a random number, say a half, and multiplied it by 0.2, I would get an answer bigger than 0.5. So what I have to do here is actually take the 0.5 minus that number, and do that, and notice that if the random number was actually 1, I would get 0.5. And if the random number is 0, I'll get the same thing I got in the before column. And then I'll get anything else in between. But see, so I could do that, and now I've got a random amount that it will go up, but every one of those is guaranteed to do no worse than they did the first time. So now, I just sort of built a model that says they do get better. Okay, so that's something I could do. Now that was just the before and after. I could also do the same sort of thing with the practice, because the numbers are still in the before after. They're still basically random numbers that have nothing to do with the practice. And so if I grab this thing and we got a little bit more data, now the practice, there's 12. Let me go up to whatever we get there, 29, sure, sounds good. So now what I can do is I could highlight these two columns and plot them, and then I'll switch the X and Y. So, or actually, I got an even quicker way to do it. I can put the after and before here, and so I just copied what was there, and now I'll highlight those two and insert a chart. And it should look quite random, I think. A scatter plot, and we'll just say finish. And it's really big. Okay, so there it is, and yeah, pretty random, right? So if I was trying to do a least squares thing with this, I would, I'm sure, end up with a really big p-value, a slope of basically of 0, and it would say nothing works there. And that's okay. Again, that's okay in that if we're making up the data anyway, well, we aren't publishing this stuff. So, this kind of thing would be fine. However, you can always set it up so that your random difference, your response variable, actually would maybe either go up or down. You could have it go down. That'd be weird for practice and so forth. But actually, a friend of mine, I think if the more he practices, the worse he gets. But so you could set it up. But again, the point is, you'll need, if you've got numerical data, if what you're working on is numerical, you will need to make plots of numerical data. Okay, and if you don't, that's a problem. Okay, so you want to be very complete, and so the question is, well, how would you make it then? And, well, you can just fill it in with a bunch of random numbers, and that's fine. Okay, but then you can make a plot, so at that point I could make this plot. Okay, any questions about anything right now? Okay, so this was, let me go back to here. This was just our explanatory and response variables, but I would think, right, there are other things that might matter. Now, some of those would be hard to get, and so I can still talk about them in my report, but I don't necessarily have to go try to find them. But some other variables, some confounders. Okay, so if I'm looking at confounders, one thing that I think actually could matter is eyesight. Might matter. Certainly if I'm fully blind, I will have a hard time. If I'm legally blind, might have a hard time. Okay, at what point, even though, like, I have glasses, so I have corrected vision. Oh, well, so I might want to keep track of that. And so what I would need to do is talk about that variable. What am I going to keep track of? And so, this could be categorical. Really, no matter what you come up with, I think you would call it categorical. The system of like 2020, 2040, that kind of thing. Well, those are real distances. Yeah, I don't know if everybody knows that, but so what somebody I guess it goes 2040, but what somebody else sees at 40 feet. If you have 20/40 vision, I think that I've got those in the right order. What somebody with what we call normal vision can see at 40 feet, you can see it at 20 feet. Okay, so those are real distances, and they're real things, that number of the 20/20 and all that. So you could call those numerical. You could figure out what the person's vision is, or you could go with a category of like corrected or uncorrected. Right? So they're 20/20, or they're wearing some kind of corrective lens. Now you probably still want to check that and so forth, but so this might be categorical. And it might be 2 levels, okay, of corrected, uncorrected. So in my original data file, I would want to show the reader, something like eyesight, and have, corrected, uncorrected, and so forth. Okay, but show us that. Show us that you would collect that data if you felt that data, was necessary, and show us kind of what it would look like. And so eyesight could be something. Now, something that'd be a little harder might be something like athleticism. Shouldn't there be a, let's see, athleticism? Is that athleticism? Or should there be an S there? Anybody know? I got Google here, I could look it up, but, you know. Anyway, what is it? Oh, you're looking it up. Awesome.
It's a C.
It is a C. Okay, so athleticism, you know, oh, that could be really tough. And maybe it's self-reported or something like that. And that, you know, probably I would have as a, you know, like a high, medium, low kind of thing. Whatever that might mean. But I might have them self-report that. Okay. So, you know, maybe athleticism matters. Now, notice a lot of these, again, eyesight wouldn't necessarily have to be categorical. It could be numerical. But in this particular case, as I'm thinking of these, a lot of them seem categorical. And another one that I think could impact this, possibly, is handedness. And you might think, right, you might think that's, at first you might think, oh, that's a 2-level categorical. But no, 3. Because someone may be classified as ambidextrous. And wouldn't that be interesting if somebody who's considered ambidextrous actually does better? Oh, that's a whole different study, right? But it's because it might matter whether you're right-handed, left-handed, or ambidextrous. So right-handed, left-handed, or ambidextrous, you know, we could put that in. Now, and I might be able to come up with some more. Okay, but let's toss in the handedness here. And, you know, that could be an R, that could be an L, that could be an A. And so, you know, I've got my raw data like this, and that's what I mean when I say, what would your data look like? Okay? It would look something like this. And now you can tell me that you would try to get 20 participants. You can tell me that you would try to get 20,000 participants because of whatever you're trying to do. Right? If you were doing something where you gathered your data from a survey on, I don't know, what are you all doing these days? Is it TikTok? Is that old too already? I don't know. What's you know, but something like that. But, you know, survey on one of those things, right? One of these various social media things. You know, so you put a survey out there, and you just, you know, you might get 20,000 respondents on something like that. You know, especially if you can tag it with some very popular video or whatever that somebody's trying to look at. So. But imagine that, you know, so say you thought you were going to get 20,000. We don't need to see 20,000 lines of data. Okay? Doesn't need to happen. If you look at most of these studies, they don't show you the raw data other than maybe a sample of it like this. Now, this is a class, so I want to see a sample of it because I want to see that you have thought about how that data would look when it comes in. Okay, so you would show something like this. But then you would also show what you're going to work with, right? And so what you're going to work with would probably be something like your number, that's the number of practices. You'd probably still have your participant here. Okay, now you would have, in this one, probably the difference. Okay, the after minus the before, you would have the difference here. Right, and what we should see in here, they don't necessarily have to be all numbers. But in this case, where I'm talking about looking at two things that are both numerical, yeah, probably these other things should be numbers. Now, if you're looking at all categorical data, you might be able to just leave it as those categories, those names, those levels. But just to point out, and this is where I want to use the handedness, okay, what I might do is, since most people are right-handed, it's probably that would be a good base case, because again, this is categorical. So I would write, if I've got the numerical and I need to mix in some categorical, I'm going to do them as dummy variables. So actually, I wouldn't have right there. I would have L dummy, okay, the left-handed dummy variable, and the ambidextrous dummy variable. Right, so this is the data you would actually work with, and this is showing me you understand that, right? That if you want to analyze a couple of numerical things, and you've got some of these confounders that are categorical, you're probably going to need some dummy variables. And so you would, here's participant 1, 2, 3. Again, we had some numbers here, differences. But here, most people are right-handed, so you probably see something like 0, 0, 0, 0, lots of 0, zeros. But then there's a 1 and a 0, and here's a 0 and a 1 to show, oh yeah, I might have some left-handed people, I might have some ambidextrous people. But of course, these are the right-handed people. But you would just show, a few lines of a table like that to show how your data would actually work in your analysis. Okay, and you would explain what the heck these dummy variables are. That your base case is the right hand, and then you use left and ambidextrous for the other. Now, if this was your actual study, well, you don't have to use the right-handed people, but our textbook mentions, and I have mentioned, a base case, whatever happens the most frequent case, that's usually not a bad one for a base case. There might be reasons why you wouldn't want that, but often that's pretty good. Okay, so you would show this kind of data that you're getting ready to analyze. Okay. Now, what else about your data? Okay, I showed that, okay, we could do a plot here between those two to kind of show what's going on. But remember, we don't want to use two variables that really could be interchangeable, that kind of thing, or have a great dependence on each other. So let's take, in this case, for one, I could look at the categorical variables with the different numerical ones, but let's kind of switch up gears. So what if I've got a bunch of categorical variables? What do I do in place of a plot? Now, you could still kind of do a plot if you really wanted to, but it's probably better not to. So, for instance, here with, I had, let's go with the eyesight and the handedness. Okay, now, you could say that for a plot like this, and this is part of the reason it's not the best, but, the eyesight, I could have a 0 and a 1 there, and here I could have a 0, 1, and 2. I'd have to tell a person what they meant. But here's the problem, is if I did a plot, it would look like that if everything filled in. That doesn't tell me a darn thing, right? So that's a problem, right? And that's why it wouldn't be a plot. What you want to do is a table, and you could just look at, right, left, ambidextrous, and there's the hand. And this takes the place of, and here's corrected, not corrected, and eyesight. Okay, so with this data, what you want to talk about is that you would like to check out that relationship. Okay, you'd like to pair up all your confounding variables with each other. Okay, in this case, they're both categorical, so I guess what I need to do is do a count, and, who knows, 10, 5, 8, 7, and 4. That probably wouldn't be it with the ambidextrous and so forth, but, suppose I had something like that. Now, as I look at that, I think, yeah, that's probably independent data. Okay, but what can you do? This is then part of your analysis. So here's the data, but your analysis then, you can run a chi-square on that and get a p-value. And this is a case where a big p-value is just fine. Okay, because a big p-value would mean, oh yeah, these things are independent of each other. I should consider them both in my analysis. Okay? So on your data, you want to compare each and every one of these. And so if I've got two categorical pieces of data, I'll probably use a table and then maybe do some kind of a p-value from a chi-square. Now, if you have, in this case, so suppose I want to check handedness and my number of practices. I split people up probably randomly, but did I accidentally have all the left-handers practice a whole bunch more? Right? Oh, that would be a problem. And I would like to know that before I do my analysis. And so you would have a choice of either, so here's your right, left, and ambidextrous, and then your number of practices, 5, 10, 20, another 5, a 5, a 20, a 20, a 5, and a 10, something like that. So these were the number of practices various people have. So just to show you that this is not a table in the sense of lining anything up, we could put a 25 there, and we could put a 5 and a 0 there, or something like that. Right? So that would be my data sorted by the handedness. And I could either run an analysis of variance and ANOVA on that, or I could just use my dummy variables here and run it with, these as my explanatory in a multiple regression and that as my response to do the same thing I did here with an analysis of variance. Okay, but the big point is you should mention some confounding variables, go into them, have them in your data, and then actually talk about looking at their relationship between each other and then the main variables of interest. Okay, so there's a lot to do there. And some of it is analysis because you would run p-values on those to decide whether they're dependent or independent. Because again, if they're dependent, you probably don't want them both in your analysis because one's as good as the other. It's not always true, but often that would be the case. And so you just want to take that time to do that. So, as you work on your projects, your data and analysis sections should be pretty fat. Okay, how fat? How big? I don't know. Okay, 2 pages, probably not enough for each part. Partly because you should be showing plots and output of, your templates, that kind of thing. And then, 30 pages each? Probably too much. That's kind of overdoing it, I think. I don't want to look at all that, right? So, try to be succinct, get to the point, but show that you understand you should really look at relationships among all the variables, not just the 2 that you're most interested in. Okay? All right. And we're a little over, so next thing is just turning in your project. If you have any questions on anything, just let me know. If you have any trouble making the VoiceThread presentation, you can delete earlier VoiceThreads, start with the oldest. But I did just find out this semester that you can have as many as 5 VoiceThread presentations with a free account. So if you try to do a 6th, you have a problem. So like your introduction video, you could get rid of that. That kind of thing. If you have any trouble with it. All right?